Alrighty, my name is Elric, and this video is meant for my coffee page. I will be discussing the unit of measure pack that I have up, which is a 5-table structure that has all this unit of measure data into it. So I'll go ahead and explain the files. Check the description below to skip, bookmark, all that stuff. So the files themselves, what is included in this pack is 6 SQL files and 2 data workbooks, basically, an open document and an XLSX, just in case you do not use SQL, but you're still interested in the data and you don't have to mess around with one of these SQL files to extract this data. All right, so the first 2 files, the with abstract SQL UDTs and without UDTs, are the table structure. So the with UDTs will give you the user-defined types that I use, so everything is more strictly defined and works with the system that I am creating, that I have created, that you will find in another pack. So this is all the tables and their indexes and defaults. The without UDTs is the same thing, but you will notice that they use native SQL types versus actual user-defined types. The second piece that you'd run second are the views, the translation between the not so human readable columns to a more human readable item. The select, insert, update, delete views, and the base views for each of the 5 tables. The third piece is the function itself, and now I will show a demo of this, but just to go through this quick, this function accepts JSON, both input and output. You can do some modifications if your version of SQL doesn't support JSON. I believe I'm not doing anything special with the OpenJSON, so this should work in 2017 plus. But most of my stuff will only work in 2019 and later. So I believe you're okay though, just because in 2019 I can actually add parameters to my path. And in 2017 we can't, but it doesn't look like I'm doing anything like that in here. So this code is pretty simple, declaring my variables, getting the information from the incoming JSON, looking up my IDs, and then a forward recursion, a recursive CTE, which will allow me to go from seconds to year. And I build a tree, which I'll explain about in just a few moments. And if I did not get any data back, then it's probably I have to go backwards, like from year to second. So I'll make another attempt. And if I have a tree, I will go ahead and split the items in the tree to grab my factors, do my simple math. If I'm going forward, I will be dividing my factors, and if I'm going backward, I will be multiplying my factors, because math is really simple at its core, and I will be returning this data. So the value as it is converted, the ID tree it took, the human readable tree or path that it took, and the coefficient that was used in the mathematics. Just in case something is off, you can see that coefficient. You know, if you're going very large to very small, sometimes we'll hit floating point issues. So this will give you some insight into what's actually happening. And using JSON allows you to modify this function to get other data back, which is a lot more powerful than using standard single value return type of function. So the fourth item in this is all the data. So this is all of the data that's inside system. And I will do a quick demo on that also in the example. So I'm going to go ahead and close all of these. And now I have the fifth file, which is an example file. Get to the place. All right. So we have a from and a to. So from second and to, I'll be calling this function. So the output of this function says the actual value, 500 seconds in terms of year, is that 15/100,000ths, and the coefficient conversion was even lower than that. So many zeros, it makes it hard to read. But I can also do the inverse. I can go from year to second. If I run that, I get my, well, explain the path too, but 500 years is this many seconds, and this is the coefficient that was used. This is the path that was taken. So it went from a normal calendar year to the mathematics to day to hour to minute, then to second. If I undo and run it again, see that went from second, minute, hour, day to a normal calendar year. Why is it normal calendar year, you ask? Well, let us steal this. Let us look at why. So in my structure, I have 5 tables. The realm table is the topmost table. The class table in a hierarchy is the next one down. The class table has a realm ID. The family table, next one down from class, has a class ID as a foreign key. Then we move to type, and finally we're at our base. So this is the table structure where each one is dependent on the one above it. So you cannot have unit and measure data without a type, cannot have type without a family, cannot have family without a class, cannot have a class without a realm. So inside of our realm is our first type of classification, where we have 3 primary items: the formulaic, the factor-based, and the currency. Formulaic is meant for temperature, something that has a specific formula that's not really factorable, like Fahrenheit, Celsius, 9/532. Factor-based is one of the most common ways to get in between units of measurement. Thank you, metric system, going from giga to mega or kilo to deca, whatever. It's factor-based. Even foot to inch is factor-based. We have a specific and constant factor between 2 units of measurement. And finally, we have currency, which is time-based. So we do have the ability just to say, hey, this is a US dollar. However, we also have the ability to say this was a US dollar in 1979 and add the appropriate conversion steps to account for inflation. This is a very powerful model, and it's going to take a lot of work to get there. A really, really great piece of work, but I figured I'd put this on my coffee page now as I add to it. So the realm is pretty simple. The class would represent our basic 7 units of measure, or classes of units: our length, our mass, our time, electric current, substance, luminosity, and temperature. So for family, I kind of left it open, and just to reiterate, I'm using unassigned on all of my types right now because of the complexity, because I'm no subject matter expert. So if you want to contribute to this model, do find me on LinkedIn, same name. So the family is all assigned right now. This is left open just in case the individual wants to use like radiation or magnetism as their family to further break down what's happening in that chain. This will allow us to get very fine-grained tuning as we look into our type data. So we have 134 different unit of measurement areas: energy, area, permeability, mobility, all sorts of stuff, even just standard units, like just a unit. So our unit of measure table, the lowest one, the most atomic structure, is where all the magic happens. If I come down here to time, which is 120, I've done this so many times I remember the ID. It might make more sense because time is a very common understanding. So I have second, moment, jiffies in here, different slices of a year or a month, because months are different, and if you're looking to convert to a month, there's an approximation. I even have, our fortnight, our blink. So how you would read this table or utilize this table is a blink is 1/10,000th of this ID. So if I come in here and I say 700 blinks, in order, I would have to multiply and I will get this ID. And 179, the day. So a blink is 1/10,000th of a day. And then from a day, get to 78 hour. I would just multiply that value by 24. So this is where the recursion comes into play, where I can find a path, multiply if I'm going more atomic, or divide, divide as I'm going down, multiply as I'm going up, right? Yes, that's correct. But the data is here to allow us to make those transitions. One of the things I'm going to do is create a script. I am testing it, and there are specific pieces that do not fit well where we can just move to a base, because that is one of the flags in here. It's base, where measure base flag is 1. So we have specific bases in each of our measurement types. So this will allow you to go quickly to a base unit if you store everything in your base units. So that is the entire model that is up on this page. So thank you very much for supporting. If you want to add to this model, you are a subject matter expert, please reach out to me on LinkedIn. Thank you again. Hope you enjoy. I'll see you next time.